Hey everybody, it's Miss Williams, and this is the notes for TrigDay1. We're going to talk about coterminal angles, converting radians to degrees and degrees to radians, and finding trig ratios using SOHCAHTOA. So the first thing we're going to do is the unit circle, and it is a circle whose radius is 1, and the center is at the origin on a coordinate plane. There are 360 degrees in a circle, and this is what a unit circle looks like. The 0 degrees is always on the positive x-axis, and as you go counterclockwise, you positive, so 90 degrees, 180, 270, 360, and it would continue to go around over and over and over again. You would continue to count positively as you move counterclockwise. If you move clockwise, you would count negatively. All right? Coterminal angles are angles whose position on the unit circle is the same. You can find coterminal angles by adding or subtracting 360 to the original angle. Find a coterminal angle to 65 degrees. Well, you do 65 plus 360 gives you 415 degrees. You could also do 65 minus 360 and you get negative 295 degrees. All three of these would be the same position on the unit circle, so they're all coterminal angles. Okay. Next we're going to talk about going from radians to degrees and degrees to radians. Radians is just a way to measure angles, just like we can talk about miles or kilometers. They're both measuring distance. So 360 degrees is 2 pi radians. Likewise, 180 degrees would be 1 pi radian. So can you convert 100 degrees to radians? So all you have to do is use that second ratio that we talked about. 180 is equal to 1 pi radian. 100 degrees times pi over 180, because you're going to radians. The radian part is going to be on the top. And then when you reduce your fraction, you get 5 pi over 9. Just leave the pi in the answer. You can go the other way. You can go from radians to degrees. You just have to remember to put the degree part on top. So 6 pi radian, and then multiply that by 180. No, 180 over pi, and you get the pi's actually cancel each other out. And then you end up with 180 over 6, which is 30 degrees. Finally, you should remember SOHCAHTOA from geometry. You can only use it in right triangles. It helps you find missing sides or angles. So what does SOHCAHTOA stand for? Sine of theta in this circle with a line through it is theta. It's kind of like a x, but we use it usually to measure angle measures. It's opposite over hypotenuse. Cosine is adjacent over hypotenuse, and that should say tangent is opposite over adjacent. And here's what a right triangle would look like with the opposite, adjacent, and hypotenuse. And I can't get this to